This is the O-Levels 2011 Science Chemistry paper. You are provided with a sample of solid salt Q, which contains 3 different ions. So we are supposed to carry out the experiments and test for any gases evolved. The first part, use a spatula to transfer approximately 1/3 of solid Q into a dry hard glass test tube. So this is the dry hard glass test tube. Use a spatula 1/3. So you just need to estimate 1/3. So it's about less than half, 1/3. So well, they're about so. Okay, so I think this is about right. So this is about 1/3. Heat the sample gently for 30 seconds and then very strongly until no further changes are seen. Test any gases evolved using red and blue litmus paper. So before we heat, we will put on the safety goggles. To turn on the Bunsen burner, first you close the air hole. This is the air hole closed. Turn on the gas completely. And then you light. Heat it gently for 30 seconds first, and then very strongly. So gently means we would use a weak flame and orange flame. Typically, we will heat gently always at first because the test tube will be cold. You do not want the expansion to be too rapid at first. So you're basically trying to let the test tube warm up, literally warm up. So the decomposition of the salt would have started. So 30 seconds, well, about there. Heat it strongly. To get a strong flame, you open air hole. You can hear. You can see the blue flame. You can hear it. So the moment it starts, you got to pay attention to all the observations that is happening. So there is some water droplets, and then there is white fumes. So all these are observations that you will write. And then there is also a color change that's happening to the solid already. This is the initial color, pale green. So this is a color change happening. We are supposed to test. The instructions for the testing of the gases comes later in the same box, but we do not wait too long to test for the gases. So we would test it right now. We are going to test using red and blue litmus as instructed by the question. But we need to know that whenever you are doing tests using red and blue litmus, you must always dampen. There's no need to only dampen it at the sink. You can afford to use part of your bench. You will have sufficient space. So I will use the deionized water, and then I will wet a part of my table, a part of my workbench. Just put the water, spray a little bit of that water onto the table, and then dampen it using that water that is on the table. I would now test for the gas using both the red and blue litmus at the same time. So it takes a bit of practice to hold the red and blue litmus carefully. So we're going to test for the gas at the same time. So you insert sometimes the gases may not appear immediately, may not be produced immediately. So you just have to keep try a few times. And as you put it in, you do not allow the papers to touch the sides of the test tube. So I do see a color change happening to my red litmus. Now for my blue litmus. You just want to wait to see if you would get a color change as well. So the red litmus is definitely done. Now for the blue litmus. And of course, while you are testing with the red and blue litmus, now the blue litmus only, you want to also be paying attention to the solid because there are also color changes happening. The hottest part of the flame is the top the tip of the small blue triangle. If you wait long enough, like now, you will see that the blue litmus will also turn green. So this was the blue litmus. So we see that gases are produced. Certainly it must be the work of two different gases. One that turned the red litmus blue, the other that turned the blue litmus red. And then the solid has certainly changed color and is more than one color. So these are the colors observed of the solid that is left behind in the tube. All of these observations need to be recorded as part of your answers in part A. So the white fumes, the water droplets at the side of the test tube, the yellow, white, brown solid that is formed, the damp red litmus paper turns blue, the damp blue litmus paper turns red. So all of that will be included in your answer for part A. And then that's it for part A. So whenever we are not using the Bunsen burner, close the air hole. You can leave the fire on, just have the orange flame so that you can see the flame. It's safer that way. The next step, transfer the remainder. So the remainder, what is left inside the canister, transfer the remainder of solid Q into the large test tube labeled Q. So they may not, in this case it's not labeled, but certainly this is larger than the test tube, so this is the large test tube. Half fill this test tube, so we transfer, because it's a boiling tube, it's bigger, so you can actually pour. Of course, do it carefully. So you can pour the remainder. They didn't say how much, they just said the remainder, so just pour the entire thing, the remainder. Half fill this test tube with deionized water, half fill, so about half. So you put solid Q into the boiling tube and then you add water. Obviously what you're trying to do here is to make your own solution Q. So the solid dissolve, you get solution. When you shake, there will be bubbles, but that is not bubbles due to a chemical reaction. It's because you shake, right? So you shake any liquid, you are going to generate some bubbles. So this is not an observation. This is just intermediate step for you to prepare your own solution Q. So we'll just shake to mix because they say that this is solution Q. Invert until all the solid has dissolved. So the instruction were to clarify that it would dissolve, that it would dissolve. So this is solution Q, solution, no solid suspended inside, you can see through, light can pass through completely. So this is solution Q. You must retain solution Q for use in parts B, C, and D. So this is solution Q. So we're going to put this as at one side. Place 3 cubic centimeters of solution Q. So this is the solution Q. There are markings on your tea pipette, the dropper. So if you're unsure how much is 3 cubic centimeters, is you can't see it on the video, but it's basically this line. Okay, when you actually see it, you can observe and look at and find the number. This is 3 milliliters. So they're about. So this is not yet. This is about 2. They asked me to put 3, so I add 1 more. So estimate the height. So the height of it would be about a little bit more than the little finger, a little bit more. Okay, somewhere there. This is how I will leave my tea pipette in the solution Q. To this solution, add 3 or 4 pieces of magnesium ribbon. So this is magnesium ribbon. When I see that I'm issued magnesium ribbon or any other reactive metal, I'm careful, as in, because I know I have to test for any gases involved. Before I put this in, I would actually be expecting bubbles already, even though I don't know what's Q. But I do know that I added deionized water. And magnesium doesn't take an acid to react. Magnesium is reactive enough to even react with water. So what I do is, I'll still, of course, follow the instructions, put it in, and true enough, there are bubbles that you can see. So there are bubbles And so whenever there's bubbles, there's a gas, and then you must test. So bubbles seen in B, the first box. So when there's bubbles, you must test. The next box says gently warm the mixture. So then the question is, what test should I carry out for this gas? Given that it's magnesium, a metal, my choice is I would go for a splint test, lighted splint. So lighted splint test, this is lighted splint with the fire, so you can try. So I'm fairly certain there is hydrogen, but it doesn't give me the pop sound that I'm expecting, although it did extinguish my lighted splint. So I will, heat it up as the question suggested. Gently close air hole, orange luminous flame is good. The reason is gentle heating is because you're heating solution. You don't want to have the fire so strong to cause the solution to shoot out. That will be too unsafe. So now the bubbling is more vigorous. There is more hydrogen given off. So maybe it will give me a better observation. Unfortunately, I still don't get the pop sound. That doesn't mean no hydrogen is given off. I'm still actually very certain that definitely there was hydrogen. There is hydrogen right now. It's just that too little of it is given off to generate the pop sound. So in this case, because I'm actually very certain, since this is not an unknown, this is just labeled magnesium, I will write in my answer that lighted splint extinguishes with a pop sound. So let me try again. Lighted splint, no pop sound, extinguishes. But I will write that it extinguishes with a pop sound. We need to, while you're doing the gas test and busy with the lighted splint, the solution has also changed color. So it was colorless, now it looks a little bit yellowish, brownish. The instruction says leave this test tube to stand in the test tube rack for a few minutes. When they say that, and nothing else, they say while you're waiting, continue with part C. What they're saying is leave it on the rack, but before you leave it, you take a look at how it looks like now. Remember how it looks like? Later, when you come back, you are likely to see a difference. So this is how it looks like at the start for section B. The few minutes will pass when we do C and D. So by the time we are done with C and D, we're going to come back to this test tube B and see how it would be different by then. So this is how it looks like. The bubbling is still there. So you leave it aside and then you just make a note. Okay, this is the test tube B on your rack. So we are going to continue with part C and D. Part C, place 2 cubic centimeters of Q in a test tube. So this was my solution Q. I take 2 cubic centimeters. Okay, so there are about 2 cubic centimeters, somewhere there. To this solution, add 2 cubic centimeters of sodium hydroxide. Sodium hydroxide, 2 cubic centimeters, so just double the volume, roughly. And always shake after you add. There's no need to add excess because the question didn't instruct you to do so. Certainly now you cannot see through it, light cannot pass through. This is what we call a precipitate. So of course the color is dirty green precipitate form, green PPD form for the first observation in part C. It goes on to say gently warm the mixture. Before I actually do it, I again will be thinking, I just added sodium hydroxide. And then I am instructed to warm. This combination of sodium hydroxide and warm is a specific test on a specific ion, which I would be thinking, I am actually now trying to test for the presence of ammonium ion. And how do I know if ammonium ion is inside this tube now? Well, I need to test using damp red litmus paper. So you take out another piece of damp red litmus paper, of course a new one, and then there is the puddle of water on your workbench that is still water. So I will get ready my damp red litmus paper, and then I heat. So you will realize by now that it takes you some effort to think beforehand before you start doing. So you don't, of course you obey the instructions and heat as they tell you. Okay, this solution is very frequently bubbles very vigorously. So this is how I would hold my red litmus. I will not hold it like that in the way of the solution, because if the solution were to accidentally squirt out, it's going to hit me. So what I would do, my damp red litmus, I will hold it this way, so that the paper is in the way of the gas if the gas is coming out, but my hand is not. So my left hand is holding on to the test tube. As soon as I feel it bubbling a bit more vigorously, I will move it away, but I continue to test for the gas. So I move it away, but I continue to test. And then now I see that the damp red litmus has started to gradually turn blue. And if you really want to confirm, put it all the way in, and it certainly definitely is blue. And so this is a positive test that ammonium ion was present, because ammonia gas was given off. But in your observation, you do not write ammonia gas because you didn't see ammonia gas. You only saw that the damp red litmus paper turns blue, and that's why you write damp red litmus paper turns blue. Gas, colorless gas, turn damp red litmus paper blue. And at the same time, your dirty green solution, PPT, has also changed to a little bit of brown. That you should also write. So whatever color changes you see, you write for the exam. So part C, dirty green PPT form. Gas turns damp red litmus paper blue. Upon heating, green PPT turns brown. Gray, I think. A bit brownish, yeah. So then I still have part D. Put 2 cubic centimeters of Q. This is the Q. 2 cubic centimeters in a clean test tube. To this solution, add 1 cubic centimeters of dilute hydrochloric acid. So hydrochloric acid 1, so half of this initial volume. Half of this initial volume. Okay, you should know that this hydrochloric acid is not the reagent. It's actually the chemical you add to provide the acidic environment so that the reagent, barium chloride, can then carry out the test, which is to test for the presence of the anion sulfate. And how would you know whether there's sulfate? Well, you would find out when you see whether there's a white PPT that will be formed. So you add 1 cubic centimeters, then instantly the PPT forms. You always shake. Now that you have shaken the test tube, light cannot pass through. This is white PPT form. For part D, white PPT form, which confirms that it's sulfate, but you will not write sulfate because you cannot see the sulfate. You only see white PPT. All the names, ammonia gas, sulfate ion, iron 2 ions, these are part of a conclusion that you will write in part E. Always. Okay, names only appear in the conclusion. Observations will always be what you see. So we have come to the end. We have finished part C and D, but we do not forget that we have a part B test tube. So this is the part B test tube. So the difference is not huge, but there is some difference, especially when I took a look at the top part of the test tube. I see that there's a bit of yellowish, brownish color, solid, that is formed at the top of the part B test tube. So I will write in my answer, in addition to what I've written already in part B, I will write upon standing or after a few minutes, brown solid form at the top of the solution in the test tube. If you shake, then there's a lot of black solid that will be formed. I mean, you could also write the black solid. Mostly this black solid right now is largely because the magnesium metal, being very reactive, would have corroded even before you started your experiment. So magnesium metal isn't meant to look so black. It's not meant to look so black and dark. It's meant to look silvery, shiny, but because it's such a reactive metal, you rarely get a very, very clean piece of magnesium for experiment. So in this case, this is the reason why I would you can see that I kind of avoided talking about the black solid, because really the black solid had been there at the start, which is not the magnesium metal anymore. So I will write brown solid form, and I'm not surprised, because after I'm done with part C and D, I'm fairly certain that actually there must be iron 2 ion. So leaving the test tube to stand, allowing oxygen gas in the air to go into the test tube, and then oxidize the iron 2 to form iron 3, giving it the brown color. Well, it's pretty logical. So that is the reason why I'm also quite certain of this observation that it's a brown solid form. Yeah. So this is the 2011 paper.